This is section 8.5, part B, dot and cross products of vectors in space. You can use the cross product to find a vector quantity called torque. Torque measures how much effectively a force applied to a lever causes rotation along the axis of rotation. The torque vector T is perpendicular to the plane containing the directed distance r from the axis of rotation to the point of the applied force, and the applied force F as shown. Therefore, the torque vector T is equal to r cross F, and this is measured in Newton meters. Now, before we get started on this problem, we need to think of your x and y axis to be on the floor. X would be like east and west, y would be north and south, and you think of your z-axis as going up in space or going down into the floor. So Robert uses a lug wrench to tighten a lug nut. The wrench he uses is 50 centimeters or 0.5 meters long. We need to find the magnitude and direction of torque about the lug nut if he applies a force of 25 newtons straight down to the end of the handle when it is 60 degrees below the positive x-axis as shown. Now remember, we said torque is measured in Newton meters, so we do need to make sure our measurement is in meters. So we are going to select that 0.5 meters long. Now the force he's applying, it says he's applying it straight down. Down would be your z-axis. So our force vector is just going to be 0, 0, and negative 25 because he's applying force down. For our vector, we need to have two quantities. It says it's going down and it's directly below the x-axis. So this tells us we're going to have a value at x and it's going to have a value at z. Now just like when we were finding this in 2 dimensions, we're going to do the magnitude times the cosine of theta and the magnitude times the sine of theta. Whichever coordinate you have first will be the magnitude times the cosine. Whichever one comes second will be the magnitude times sine. Now before in 2 dimensions that was x and then y every single time, but this time it's just going to be whatever 2 directions we need. So our resultant vector for that part of our force is going to be our magnitude. It says it's directly below the x-axis, so we know it's going in the direction of the x and then going down. So we're going to have an x and we're going to have a z. So we're going to do our magnitude times the cosine of the angle. We are not going to have a y coordinate because it's not going in that direction. And we are pushing down, so this does need to be a negative 40-degree angle. And then we have 0.5 times the sine of negative 40. Again, this is negative because it says it is pushing down. Now, if we do these calculations, we are going to get that our vector r is equal to 0.38, 0, and negative 0.32. These values should make sense because it says it's in the direction of the positive x-axis, so our x value is positive, but it is going down, so that would be a negative 0.32. Now we need to find the torque. Remember, torque is r cross F. When you're doing r cross F, that means r needs to come first, so we're going to do 0.38, 0, negative 0.32, and then vector F, our force, 0, 0, and negative 25. Now just like we did in part A, if we're looking at vector I, we're going to ignore its column and use the other part, so we need to find the determinant of 0, negative 0.32, 0, and negative 25. And we're going to multiply that times vector I, minus, if we're looking at J, we're going to ignore that column, so 0.38, negative 0.32, 0, and negative 25 times j, plus, if we're using k, we're going to ignore that column, so we're going to do 0.38, 0, 0, and 0, and we're going to multiply that by vector k. Again, when you're finding the determinant, it's going to be a times d minus c times b. So if we come over here, on the first one, we're going to have 0 times negative 25 minus 0 times negative 0.32 I minus (0.38) times negative 25 minus 0 times negative 0.32 j plus 0.38 times 0 minus 0 times 0 all times k. Now in the first one we have 0 times a number and 0 times a number, so those are going to cancel out and give us 0. On the second one we have 0.38 times negative 25, and that's going to give us a value of negative 9.5. Then we're going to have 0 times this, which is going to give us 0. If this is negative 9.5 and we have minus a negative, this is going to turn into a positive 9.5j. And then for the part we're going to multiply in front of k, we have 0 times a number and 0 times a number, so those are going to cancel. So we do know that it's going to be 0i plus 9.5j plus 0k, or we can write that torque in vector notation. So this would be 0, 9.5, and 0. Now once you find the torque, you are going to have to find the magnitude and the direction of that vector. Remember, to find the magnitude of your vector, it's just the square root of the first term squared plus the second term squared plus the third term squared. 0 squared is 0, 0 squared is 0. So when you take the square root of a square root, our magnitude will just be the same value. So the magnitude of t will just be 9.5. Remember, when you're looking for an angle, the cosine of theta is equal to a dot b over the magnitude of a times the magnitude of b, or in this case, because it is just one vector, we know that since we only end up with a value in the y, the direction has to be parallel to the y-axis and it must be positive. So we're talking about the torque, which direction is it going to push it? Because we only have a y value, it will be parallel to that y-axis and it will be positive. So that will be our magnitude. It will be positive and in parallel to the y-axis. The cross product of two vectors has several geometric applications. One is that the magnitude of u cross v represents the area of a parallelogram that has vector u and vector v as adjacent sides. So if we have vector u is right here, and vector v starts at the origin just like vector u, and it is adjacent, which means they touch. If those are two sides of your parallelogram, then if we finish creating the parallelogram, we can find the area using the cross product. So again, if we do u cross v, we're going to have 4, negative 3, negative 5 and 3 times vector I minus 2 times negative 3, 1 times 3 times vector j plus 2, 4, negative 5 and 3 times vector k. When we find the determinant of each of those, we're going to have 4 times 3 minus negative 5 times negative 3 times I minus 2 times 3 minus 1 times negative 3, j, plus 2 times 3 minus negative 5 times 4. Okay. If we do our math on this, 4 times 3 is going to give us 12. Negative 5 times negative 3 gives us 15, but it is a minus, so this is going to give us a negative 3i. 2 times 3 is 6. Negative 1 times negative 3 is 3. 6 plus 3 is 9, but we do have that minus sign out front, so this will be negative 9j. 2 times 3 is 6. Negative 5 times 4 is 20, but it's a minus, so 6 minus negative 20 is going to give us, let's change that for a second because I wrote down this vector wrong. It should be 2, 1, 4, and negative 5. So this is going to be 2 times negative 5 minus 1 times 4. So let's fix that. So 2 times negative 5 gives us negative 10. 1 times 4 is 4. Negative 10 minus 4 gives us a negative 14. Okay. So our u cross v is going to be the vector of negative 3, negative 9, and negative 14. Now what it tells us is if we find the magnitude of this vector, that'll tell us the area of this parallelogram. Remember, when we find the magnitude of a vector, it's just the square root of the first term squared plus the second term squared plus the third term squared. And if we find this magnitude, it's going to be approximately 16.9. So the area of this parallelogram is going to be about 16.9 units squared. 3 vectors that lie in different planes but share the same initial point determine an adjacent edges of a parallelepiped. This is a polyhedron with faces that are all parallelograms. The absolute value of the triple scalar product of these vectors represents the volume of the parallelepiped. So we're going to do the same thing we've been doing with cross products, but we're going to add values across that top line. Instead of I, j, and k, they are going to be numbers. So we're going to set this up the same way, but after we're done, instead of it just being I, we're going to have a number that we actually have to multiply by. And when we're done, this will give us the volume of that parallelepiped. So we have T, U, and V. T is going to be the one that goes across the top. So we have 4, negative 2, and negative 2. U comes next. So we have 2, 4, and negative 3. V comes last. So since this is I, it's going to be 1, negative 5, and 3. We're going to ignore that top row just like we did when we were I's, J's, and K's. Since we're going to deal with 4 first, we're going to ignore its column. And we're going to do the determinant of the other parts. So that's going to be 4, negative 3, negative 5, and 3. And that's going to be times that 4. Minus, we're looking at that first negative 2, that second column. So we're going to ignore that column. We're going to do the determinant of 2, negative 3, 1, and 3. And we're going to multiply that by the negative 2. Plus, we're going to use that second number 2 now at the top, or the third column. So we're going to ignore that third column. We're going to have 2, 4, 1, and negative 5. And we're going to multiply that all by that negative 2 that is on top. Again, we're finding the determinant. So we're going to do 4 times 3 minus negative 5 times negative 3. And all of that's going to be times 4. Minus 2 times 3 minus 1 times negative 3. And we're going to multiply this by negative 2. Plus 2 times negative 5 minus 1 times 4. And all of this times -2. 4 times 3 is going to give us 12. -5 times -3 is going to give us a -15. 12 minus 15 is going to give us a -3. So this is going to be -3 times 4. Minus 2 times 3 gives us 6. -1 times -3 gives us 3. 6 plus 3 is 9, but there's that negative out front. So we have minus 9 times -2. Plus, we have -10 and -4, so this is going to give us a -14 times -2. -3 times 4 gives us -12. -9 plus a -2 gives us a positive 18. -14 and -2 gives us a positive 28. If we add those all together, we are going to get 34. So our parallelepiped is going to have a volume of 34 cubic units.